Hello everyone, today's topic is vector space, and in this video I am going to discuss about what is a vector space, vector subspace, and some of their examples. And also you can ask your doubts through the comments section. And yeah, do not forget to subscribe and hit the bell icon to my channel for getting latest updates. So now let us get back to our topic, that is vector space. See, the vector space. Let F be a field and the elements of F are called scalars, and let V be a non-empty set whose elements are called vectors. Then V be a vector space over the field F denoted by V over F if there is an internal composition in V called addition of vectors, which is denoted by plus, such that for this composition V is an abelian group. That is, V plus is an abelian group. Okay. So this means that it should satisfy all these 5 properties, that is closure under addition, commutativity, associativity, additive identity, and the additive inverse. See here, if x and y belongs to V, then x plus y belongs to V, that is closure under addition. And similarly here x comma y belongs to V, and the commutative law, associative law, identity law, and additive inverse, all these 5 properties will be satisfying. Next, the sixth property is there is an external composition in V over F called scalar multiplication and is denoted multiplicatively. That is, a into x belongs to V for all xy belonging to V and a belonging to F. In other words, V is closed with respect to scalar multiplication, and V also satisfies this distributive, associative, and identity laws. These are left and right distributive law, associativity, and the identity law over scalar multiplication. Okay. So if these 10 properties are satisfied, then the set V is said to be a vector space over F. Okay. Next is, what is a subspace? A subspace of vector space V over the field F is a subset of V which is itself a vector space over F when the addition and scalar multiplication of V are used. Okay, that means a subspace of a vector space V should satisfy all the properties of a vector space, that is all those 10 properties. Okay, if all those 10 properties are satisfied by a subset of V, then that is called a subspace. Okay. Now here every vector space has 2 subspaces, that is the zero subspace and the vector space itself, and these 2 subspaces are called the improper subspaces. Okay, and the subspaces other than these 2 subspaces are called the proper subspaces. Okay, one step test for subspace. Okay, a non-empty subset W of a vector space Vf is a subspace of V over F if and only if AU plus BV belongs to W, for all AB belonging to F and for all UV belonging to V. Alright, if A into U plus B into V belongs to W, then W is said to be the subspace of a vector space V. Alright, now let us see whether this is a vector space or not. Okay, so here R over R is a vector space. Okay, because if we take any element from R, like suppose this is 1 and this is minus 2, then the product of this is what? 1 into minus 2 is minus 2. So this also belongs to R. So therefore this is a vector space. Alright, now next let us check for R over C. Alright, for R over C, if we take any element from C, say 1 plus I, and from here let us take one element, say 2, then the product of these two will be 2 into 1 plus I. Now we can see that this does not belong to R. Okay, so therefore R over C is not a vector space. Alright, so this is not a vector space. Alright, now if we take C over R, alright, if we are checking for C over R, then this will be a vector space. Let us see how. If we take any element from R, let us take this as 3, and from here let us take 2 plus I. Okay, then the product of these two is what? 6 plus 3I. Alright, now this belongs to C, isn't it? So therefore this is a vector space. Alright, because see, according to the definition, here AX should belongs to V if X belongs to V and A belongs to F. So therefore, according to that definition, C over R is a vector space, R over C is not a vector space, and this one R over R is a vector space. So this means that any smaller set over the bigger one can never be a vector space. Alright, because see here what we know that, see, because the natural number is contained within the whole numbers is contained within the integers, and the set of integer is contained within this set of rationals. Alright, and this rational and irrational set is contained within your the set of real numbers, and the set of real numbers plus imaginary numbers is contained in the set of complex numbers. Okay, so therefore whenever here we will have a smaller set and here a bigger set, then this is not going to form a vector space. Alright, but the converse will. So always if here is a bigger set and here is a smaller set, then only this is going to form a vector space. Alright, and also the smaller set should be a field. Alright, this should be a field, then this will be a vector space. For example, if we take an example of C over Z, then this is not a vector space. Alright, this is not a vector space because this is not a field. Z is not a field. Okay, similarly R over say a QC, where QC is the set of irrational number, this is also not a field, so therefore this is not a vector space. Okay, not a vector space. Similarly, if we take Q over Z, then this is also not a vector space. Alright, but R over Q is a vector space. Alright, because this is bigger and this is smaller and this is a field, so therefore this is a vector space. Alright, and see what is a field. So F plus dot is said to be a field if F plus is an abelian group and F star dot is also an abelian group. Okay, this means F star means the set of all the non-zero elements. Okay, and apart from this, the left and right distributive law should also satisfy. If this condition satisfy, then F plus dot is said to be a field. Okay, so let us see a question from subspaces. The question is, which of the following are subspaces of the vector space RQ? Okay, so as we know, every subspace should have a trivial subspace, that is 0. Okay, so if we will put xyz is equals to 0, then let us see which of these equations will be equal to 0. If that will be equals to 0, that is if the LHS and RHS are equal, then that is going to be the subspace of that vector space RQ. Okay, so for A, if we put xy is equals to 0, then yes, see this is giving 0 is equals to 0. Similarly, B is also giving 0. So these two are the subspaces, but we can see if we put this is equals to 0, then this is not equals to 0. Here this is equals to 1. Okay, so therefore this C and D, these two are not the subspaces. Okay, so that's all for today. Thanks for watching my video, and please do like, share and subscribe my channel if you find it helpful. Thank you.